So I had the question as to how you would make a 6-bit counter. So you would want it to stop counting after 6 bits. We saw in the first video how the counter worked. How when you have a string of ones to the right, so right here I have a string of ones to the right, when everything to the right of a particular digit is ones, then on the next count sequence, that 0 becomes a 1 and these become 0, and that's how a counter works. And so that's in the first video, so if you don't understand that, you can go back and look at that. We also saw, I think in the second video, how you use that property to put two 4-bit counters together to make an 8-bit counter. So the way that works is to use the second counter as the next 4 bits. Then what you need to happen is when it's time to go to the 5th bit, that would be when, so I've got my higher value bits here, and then when I get to 1, 1, 1, 1, what I want to happen next is to get this count. And the way that that's going to work is you take the AND of your outputs from the first counter you take the AND of those and you wire those to the enable of the second counter. And so when these digits are all 1, then that enables this counter and tells this counter to start counting. Now, as soon as it does count, as soon as this goes to 1, then the first counter no longer has all 1s on its 4 digits, so it disables the second counter until the first counter gets back to all 1s again, and then it's time for the second counter to count. So that's how you can do that. Well, we can use a similar process to make this just into a 6-bit counter and not an 8-bit counter. And let's see how that would work. So with a 6-bit counter, we're saying that once we have filled up all 6 bits, then we're ready to go back to 0, 0, 0, 0. So remember, the 4-bit counter is already designed so that when you get to 1, 1, 1, 1, it naturally rolls over to 0, 0, 0, 0. We want this one, when it gets to 1, 1, 1, 1, 1, 1, we want the next value to be all zeros. So what we can do is have a load on all of these. And this is really no different than what we did in the other videos. And we want to detect when all of our outputs are 1. And so when our first 6 outputs are 1. So we're going to take the outputs from the first and second, or the first and second bits from this counter, which I have labeled as Q4 and Q6, and we're going to take the AND of those together with the AND from the first counter, and then we are going to wire that into the load, and to make the load all zeros. So when the first 6 bits are all 1s, then the next count will be 0. So this will count from 0, 1, 2, 3, up to 63, and then 0, 1, 2, 3, and up to 63. And so the last 2 bits here will never be used. Well, okay, you say, that's great. What if I want to do something a little more tricky? What if I don't necessarily want to load 0? So let's say I wanted to do something like, well, I still want to load 0. I still want it to be a 6-bit counter, but maybe I want to do something like this. 0, 1, 2, 3, up to 9 maybe. And then I want to load 42. And then I want it to continue counting all the way to 63, and then back to 0, 1, 2, and so forth. So this is a 6-bit counter. So it's a 6-bit counter. Only I'm doing something weird in this middle here, and that I decided, for whatever reason, I'm skipping all the numbers from 10 to 41. So when I get to 9, I want to load 42. So we need to think about how we would go about doing that. So let's look at all of our numbers that are involved. So I have the number 9. This is the ones place, 2, 4, 8, 16, 32, 64, 128. So 9 is 8 plus 1. So this is what 9 looks like. I also have the number 63 that I'm paying attention to, because when I get to 63, that's when I was loading 0 before. So this is 63. And now I have this new number that I'm putting in here, 42. So let's see what 42 looks like. So 42 is 32 plus 10. So that's 32 plus 8 plus 2. So that's 42. So what I want to happen is when I get to 9, I want to load this number. And when I get to 63, I want to load 0. So that's what I want to happen. Now, one thing to keep in mind is that when I get to 63, the next count on the first counter would automatically be 0, 0, 0, 0. And so that would be the next count on that counter. So if I detected this, I don't actually have to load zeros into the first one to make that go to 0. It would go to 0 naturally. So let's see how we can make this happen. Okay, I want to look at the number 9 and think about what would be unique about that value, that it would be the first time any of those show up in order to say it was time to trigger a new load. So starting from 0, when you start from 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1. 9 is the first time that you have a 1 both in Q3 and Q0. Now, it's not the first time that you ever have that if you started, say, at 42. If we look at 42 right here, starting counting from 42, if I have 1, 0, 1, 0, 1, 0, the very next count after 42, 43, 1, 0, 1, 0, 1, 1. That has a 1 here and a 1 here. So I don't want to look just for those, because if I look just for a Q3 equaling 1 and a Q0 equaling 1, well, that would be true also when I was at a count of 43. So that's not going to do it. But what will be true is when I am at 9, Q3, this is Q3, Q4, Q5. Q5 is going to be 0. So, and at any time I am bigger than 42, Q5 equals 1. And so if I detect Q5 equaling 0, Q3 equaling 1, and Q0 equaling 1, that'll be enough to detect a 9. So that'll be the first time a 9 shows up in my count. And then I would skip to 42, and I would count up to 63, and then roll over to 0, hopefully, and then get to 9 again. So I now see how I can detect a 9. So I detect a 9 this way. I saw how to detect the 1, 1, 1, 1, 1. We already talked about that. But now what I want to happen is if I have Q3 or Q5 equaling 0, Q3 equaling 1, and Q0 equaling 1, then I want to load my value of 42. I want to load my value of 42. And that means what I want to load is I want Q5 to be 1, Q4 to be 0, Q3 to be 1, Q2 to be 1, note Q2 to be 0, Q1 to be 1, and Q0 to be 0. I believe that's 42, right? That's 32 plus 8 is 40, that's 42. So when I detect this sequence, I want this to load. But when I detect Q5 equals Q4 equals Q3 equals Q2 equals Q1 equals Q0 equals 1, when I detect that, I want to load all zeros. Alright, so let's see how we could do this. We already have set up that it's going to load when they're all ones. We also now want it to load when we have that sequence or that combination that we just came up with, Q5, 0, Q3, 1, and Q0, 1. So let's see how to do that. So that would be Q0 is 1 and Q3 is 1 and Q5 is 0. So that will detect a 9. Now, if I were counting all of my numbers, that wouldn't be enough to detect a 9. I'd also have to put in zeros for these two in the middle here. And I could put in zeros for the two in the middle. It just would require a few more gates. So now I want it to load if either this is true or this is true. So either if they're all ones or if I have a 9. So I need an OR gate. Okay, so now I have an OR gate, and so that OR gate will be, it says, okay, load if either of these two things are true. But right now, if either of these two things are true, it's going to load as 0. Well, we only want it to load as 0 when they're all 1s. If we have a 9, we want it to load the value of 42. I'm going to put that 42 number right here so we can see it. So 42 was 32 plus 8 plus 2. So if I am in this situation right here, I want to load not a not zeros on everything. Instead, I want to be able to load a 1 here and a 1 here and a 1 here. But I still need it to load a 0 when I'm at 63. So what I can do is I can say that I'm going to put a little more logic in here. And so I want the logic to be that when this one is true, when I have a 9, I want to load 1s here, but if I have all 1s, I want to load 0. So let's think about this for a minute. If I have the number 9, then that means that this value is 1 and this value is 1. And this value is 0. And it also means that the AND of all of my bits is 0. So rather than loading a 1 or a 0 here, I can load the value, I did the wrong one. Hold on. I can load the output of this AND gate right here. Because this AND gate is only going to be 1 when these two are 1 and this one is 0. So when the reason I'm loading is because we met this condition that all of these were 1s, then this AND gate would be 0. So so in other words, if I would load if I'm either at count 63 or count 9. Then I'm going to load. And if I'm at count 63, then I'll call this output A and I'll call this output B. If I'm at count 63, then A equals 1 and B equals 0. And if I am at count 9, then A equals 0 and B equals 1. And I am loading on my first counter up there. If I can get back to it. That's not it. I'm loading on my first counter up here the value that's coming out of this AND gate, which I called B. Now notice when I'm at count 9, B is 1, so I'm loading a 1 the way I wanted to. But if I'm at count 63, B is 0, so I'm loading a 0. So that works. Okay, now I just need to take care of D5. Now I want this to equal 0 when I am at count 63, and I want it to equal 1 when I am at count 9. Is that right? I think that's right. Yeah. Yes, that is right. Okay, so I just need to do the same thing with that one and have that be also this input. So you see how I did that? So my overall idea was, there's probably cleverer ways to do this. I don't know, but I wanted to load at two possibilities. So I wanted to detect my two possibilities, and so my two possibilities where I wanted it to load were at 63, and at 63 I wanted it to load a 0, and at 9 I wanted it to load a 42. And so I first figured out how to detect a 63 and how to detect a 9, and I did those with AND gates. I said, okay, I have to have this conditions for 63, I have to have this condition for 9. I made AND gates. And then I took the OR of those two AND gates and I put those into load. So when either of these two conditions is true, it's going to load. Now the problem is, it doesn't load the same thing each time. So I looked at it and said, well, let me see what they have in common, and I'll just keep all those zeros. So anything where they're both zeros, I'll keep those zeros. And then let me look and see where they're different. So I want to look at the two things that I'm loading, which in my case were all zeros, and 42, and 42 is different in those three places. And I wanted it to load a 1 if I was at count 9, and to load a 0 if I was at count 63. Well, that's easy enough to do because the output of my AND gate for detecting a 9 will be 0 if I'm at 63, and but it'll be at 1 when I'm at 9. And so the output of this AND gate is going to be 1 at exactly the time I need to load a 1 into these values. And if I'm not there, then it'll be 0 and it'll load a 0.